Ladies and gentlemen, every time I step into ancient history classroom, I'm amazed at the mind's ability to connect us with people from whom we're divided by vast spans of space, yes, but also time. Take, for instance, this relief statue from around 425 BC. Your visual cortexes notice the faces so quickly. They notice the folds of cloth, the chair, the arms, and the handshake, and we start to compare that to our memories and our experiences, and we classify this as some sort of encounter. A business deal? No. Greeting? A farewell? The secret to this, the key to understanding this passage, is scraped onto the bottom of the stone in words that can be understood by the study of language or the help of a translator and careful observation. And they are as follows. Here lies Aristilla, daughter of Ariston and Rodilla. How good you were, dear daughter. How many of you, when you heard those words, felt even the smallest amount of sadness at the loss of those two parents? Could I have your hands raised if you did? I do every time I teach that inscription. I think of Ariston and Rodilla. I think of the Athens that they lived in that was in the middle of a war and also beset by plague, which probably took Aristilla from them. Imagine or consider what it is we've achieved having that feeling. If empathy is, as our previous speakers have suggested, one of the most humanizing of emotions, you have achieved empathy with somebody who lived 2,500 years ago. If, as R.G. Collingwood says in The Idea of History, thinking someone else's thoughts is the very atomic act of history, we've all done that together. And we've done that through a so-called dead language. It's not too much to say, I think, that the language ability of our minds that we all grow up with is a time machine. Our bodies are time machines that are moving us forward in time always. But the only time machine that we will have that can take us back to be with other people is our language ability. And the fuel for that time machine are the texts that survive to us miraculously through the ages. So I've prepared for you such a time machine. And if you'll permit me, let me pretend I am the doctor. You are all my assistants. There's a lot of you, but it's bigger on the inside. Where do you want to go? Well, I imagine there's an English student out there who wants to sail to Byzantium. Is there anybody who'd like to go to Byzantium? Let's go to Byzantium. Let's go. All right. We will go to about 11th century AD Byzantium. And who will we meet there? Another woman, Anna Komnene. She survived and was able to write a 15-volume history of her father's reign as emperor. But she didn't just spend her time writing history, she also was a physician, a scientist, a student of many arts. She had a salon. A remarkable character, and we can enter into her mind for so long and understand things like about the Crusades through her writing that's available to us in public domain through images that are provided by resources like the Internet Archive, from which I have taken this particular page. That was a fun trip. But you know, whenever you have a time machine, there's always one of the assistants who does something crazy. They go up to the controls and they jam it as far back as possible. So which one of you is going to do that? Well, if you do, that will take us, surprisingly perhaps, to the Bay of Naples. And around 725 BC, you'll find the first text-bearing object in the West. Any guesses what that might be? Is it a temple? Is it a scroll? Is it a tablet, perhaps? It's a pot. It's a cup. broken into little pieces, lovingly reassembled in around 1958. It's a cup. And I'm going to tell you what the text is on here. The text was written inside it, written backwards, actually, because nobody told them which was the right way when they were starting out the whole writing thing. And at this point, I feel that I must tell dons, deans, and parents to cover their ears, because while you might hope that what's told here is some law or some prayer to a divinity or something like that, what this says is, I am Nestor's cup. That's okay so far. He says it's a big cup. And may whoever drinks me to the very bottom be seized by the desire of lovely Aphrodite. Now, this sounds kind of mythical and but in fact, the closest accurate translation is something like, chug-a-lug, let's party. All right, so that was probably a comic episode of our time travel series. Let's go to something more serious, because there's people out there who are in the physical sciences and want to know about how people began to inquire into the matter. None of this Aphrodite stuff. Let's talk about what the world's really made out of. Well, we can go to around the 6th century BC through our same language time travel machine here to Miletus and enter into the company of Thales, who wanted to know what was the beginning, the arche of matter. Let's set aside, for now, in our arguments, the divine origins of things, and let's think about them as they are. Where did they begin? His answer, of course, is one that we like to have fun with. He said water. But it's less silly than you might think, and talk to a philosopher if you want to know why. Now, in 2010, I was part of a team that wanted to take this time travel fuel and provide it to as many people as possible. Wanted to refine it and make it searchable and analyzable in a way that it never had been before. We made good progress with Latin, but we found that the very first step with the Greek was blocked to us. Because the first step is known as optical character recognition. This is when you teach a computer to have a very, very simple visual cortex. You promise the computer that there are only these symbols. Don't try to think about anything else. There's just A, B, C, D. Don't worry. You turn everything into black and white, the whole world into black and white, and then you say, please tell me what's there. So if you take a page like this from Internet Archive of Charles Dickens, amazingly, computers can turn that into a text that can be searched, pasted into our emails, printed out in various ways. You can see a couple of mistakes, but gosh, it's a really great job. What about Greek? Well, here's a passage of a Greek scholar thinking about the first line of the Gospel of John, a text that says that in the beginning it was not water, but it was hologos, reason, or sometimes translated as the Word, en arche ein hologos. Wouldn't it be wonderful to be able to search that, look through it, find whenever somebody uses the word uses hologos as a phrase or something like that? Couldn't we connect all of our knowledge of when different later Greek sources talk about the Bible and so forth? All we have to do is OCR this text and do it, millions of times. What happens when you go to Internet Archive and look at this text? You get that. Now, I grant you not everybody here is a Greek scholar, but I'm guessing all of you, I'm trusting that all of you can realize that ain't gonna do. So, we kind of wound back, and a couple of us set ourselves to this task. It's hard. It's hard in part because 19th century public domain Greek texts are in a diversity of typefaces. You can't just have one size fits all. They're beautiful, though. I have to say this has been one of the great joys of doing this project. And my students, who undertook the difficult task of classifying each of these by telling the computer again and again, this is a pie, this is a pie and so is this, to the point that the computer actually got the point. Sometimes they get kind of lost in just how gorgeous some of these scripts are. Another challenge is that Greek has diacritical marks that are very important to the understanding of the language. A great example is, you guys all know the word demos, because you know democracy and you know democratic and that sort of, it's the people, sometimes it's the common people, sometimes it's the assembly. Well, if you pronounce that demos, you mean the people. If you say demos with the accent on the last word, and these are tone accents, more like the Swedish chef than like our accents. If you say demos, you say fat, not the people. It was really important to get that right. Well, one of the problems with recognizing ancient Greek, teaching a computer to understand ancient Greek, is that the symbols look different from ours. That's okay, we'll train that. We'll get the students to do that. But in addition, we have to deal with these breathing marks that show whether you add a little aspiration, an H, before a word. Then there are the tone accents, which I gave you an example of just now. And then there are other accents that sometimes come below a letter. Well, the students worked on teaching the computer to recognize these things. I worked on teaching the computer to combine them together to recognize an actual character that we can use. But we discovered it wasn't just that needed to be done. A single line of Greek recognized really wasn't enough. And so we produced an entire process that involved stages like spell check, combining results from different places, and bringing Latin script recognition into the data that we had. I was aided by a grant from Compute Canada that provided me last year with a 40-core machine that was all my own playground. Better than a time machine, as far as I'm concerned. I want to give you just one example of the kind of technique that we use, because it's kind of neat how you can solve these problems. I told you that the computer can only understand black and white. We have color page images, of course. The question is, how dark are you going to turn that color image into a black and white one? It could look like that, or you notice this next one is a slightly darker version. We discovered, when I was in Leipzig in October of the year before, we discovered that this was really critical to our results. And so our solution was to just blast through and do this at several darknesses for every page. I'm going to show you what that looks like. Here's a really light version, obviously, of that same section. When you push that very light version through the OCR engine that we produced, it comes out like this. Now again, I'm not assuming that you know Greek, but you do know that all these parentheses do not look right. And all the dots and dashes and so forth, that's no good. In addition to having this system, my colleague Federico Baschetti of the CNR in Pisa had developed a system that could say just how Greek a text was without actually knowing what that text is supposed to be about. He used the rules of language and so forth to assign a Greekness score out of 100. This gets a score of 35%. Now this is great because it's unsupervised. The OCR goes through, the evaluator goes through, and it's just running along somewhere in Guelph on a machine that I don't have to worry about. Let's make it a little bit darker. Well, you notice that the text here that's the result is starting to look a little bit more lively, but maybe it gets a 55% score. Let's make it darker still. Oh wow. Okay, we've done really well. And that's going to get a 75% score. But then, you see what happens. It gets darker still, and that right-hand side starts to corrode. Even have an R, Latin script letter, interloping on the whole thing. Now I want to point out to you, there's no way that we can reliably get a computer to find the right darkness. So what we did is we just blasted every page like that. The result is, this gets 45% Greek, the result is that for a book, you get a chart like this. Every graph stacked up against each other represents one page of a book. You have how dark you made it along this axis, And then you have the B score, named after my colleague Federico Boschetti, as how Greek it is. And you get this sort of curve, and you can pick that one page that's the best possible. Actually, you can also pick all across all of them, but that's a more advanced technique that I took. If you do that, and you go back to this text that we saw in Internet Archive was unreadable, the results that we get now is this. There's one error there. I'm hoping I can switch slides quickly enough that nobody will see it, but it's quite usable data. And we can find now, we can move on to the next stages. We can find where people talk about the beginning and talk about the word and where they connect between texts through Greek literature. So it's not only that one little passage, but in fact the entire book that it came from that we were able to OCR. And we have published a freely available archive of all these materials that scholars around the world can use, edit, improve, munge however they want. And it's not just that text, but in fact 709 at present that we make available and counting. Ideally, we'll get up to the thousands in a couple of years. Many of these texts have never been available in an open digital format before. The entire Commentaria in Aristotelium Graeca, the Greek commentaries on Aristotle, are now available for the first time in an open source form. The whole point of this, it's not to have fun with computers. The whole point of this is to provide ourselves with more of the fuel for that amazing time machine that we all have between our ears. Thank you very much.